All right, so 3.2, finding the limits graphically and numerically. So we have a lot going on here, and this is going to pretty much introduce us to the whole idea of a limit, and hopefully we have an understanding of what we are looking for when we say a limit. So we have this graph here. If I were to say what's this function equal to, I'll make this at 1, okay, at x equal to 1. If I said, what's f of 1? You would probably say it's 1, and you would be right, okay? Because if you go to x equal to 1, your output's 1, okay? But in terms of a limit, how do we find a limit? We look at what's happening as we come from the left, and we look at what's happening when we come from the right. And as we come from the left and the right, as we get closer and closer to x equal to 1, if I ask you what the limit is, and this is our limit notation, limit as x approaches 1, as we come from the left, where's my pointer? Here we go. We come from the left, we're getting closer and closer to this 3 value, and we come from the right, we get closer and closer to this 3 value. So therefore, our limit is equal of f of x is equal to 3. Okay, not 1, because as we come from the left and the right, we're getting closer and closer to this 3 value. You don't necessarily have to touch it, but as we come from the left and we come from the right, they're the same value, our limit's going to be that value, whatever that value is. And just to reiterate, to say how we read limit, this is the limit as x approaches 1 of f of x is equal to 3. Okay? You can also say the limit of f of x as x approaches 1 is equal to 3. The formatting is always going to be this. Limit x approaches c being any given value of f of x is equal to your limit. If both on the left and right side you get the same value. All right, so we're going to estimate this limit numerically. Okay, so we have a limit as x approaches 0 of the square root of x plus 6 minus square root of 6 over x. So remember, we're getting as we get closer and closer from the left into the right. We want to know what that is. So what I'm going to do is make a table of values, x and f of x for our output. X being, let's pick values from the left, being negative 0.1, negative 0.01, negative 0.001. And then we have 0.1, 0.01, I'm out of space for 0.001, which is okay. So I'm going to plug those in. So a little tip to help you out, make sure whenever you put this in your calculator and you go to your table function, make sure that numerator is in parentheses, okay? So parentheses there, and then divide by x. Or else you might get a wrong answer. You don't want that. I don't want that. You don't want that. So when you plug these values into your table, here's what you get. What's it getting closer and closer to? So as the number gets closer and closer to 0, it looks like we're getting closer and closer to approximately 0.204. And then as we come to the right, about the same. It looks like it's a little bit above 0.204. So it's going to be about, if we estimate, about 0.204. It's going to be a little bit more than that because we see from the right side it's going to like 0.20404. So we'll call it approximately 0.2041. We'll call it approximately. All right, so we got this piecewise function here we're trying to find the limit of, okay? Let's graph the piecewise. So it's x plus 3 when x is greater than 3. 1, 2, 3. And your output's going to be 6. 1, 2, 3, 4, 5, 6. Open circle here. And it's going to be a linear line that's a slope of 1. So it's going to keep going up that way. Okay. And then for x squared minus 4, the original graph of x squared minus 4 would look something like this, right? But we're only doing it from 3 over, okay? So at 3, the output's 5, okay? And then it's going to keep coming down. Look like that. Now, as we come from the left, what's it getting closer and closer to? It's getting closer and closer to 5. And then coming from the right, it's getting closer and closer to 6. They don't equal each other, okay? So when the limits don't equal each other, your limit does not exist. D&E does not exist. Okay? The left-hand side and the right-hand side must be equal to each other in order for the limit to exist. So this is an example of a limit not existing. All right, so we got the limit as x approaches 0 of 1 over x. Let's find the limit as x approaches 0. So what does the graph of 1 over x look like? Oh, that's a terrible x-axis. Let's fix that. There we go. So it would look something like this, right? As you recall. So x equals 0, right? So limit as x approaches to the right goes to infinity, and as we go from the left goes to negative infinity. This is what's called unbounded behavior, okay? If it keeps going to infinity either way, we can conclude that this limit does not exist as well, okay? D&E. Anytime we have these infinite, even if this right here was up here, and they were both going to infinity, it would still be does not exist for this particular limit, okay? They need to be going to the same specific value, okay? All right, and that is everything. Appreciate you watching, and we'll see you in class.